Let us now discuss, students, lateral shift. हमें यहाँ पूर्व बोले normal shift बर्तमान पढ़े lateral shift. ठीक है? देखो. First of all, how a ray of light is refracted through a parallel glass slab. What a glass slab पे देखिए, अलग मन आप समझते. This is air, glass air. What a glass slab देखिए light का कितनी refraction हो. This is incident ray. Let the angle of incidence be I1. Okay, this is normal. Since ray of light is traveling from air rod to glass, means ray rod bends, so it will bend towards the normal. It bends. Let angle of refraction be R1. So this is the first refracting surface. This is the second refracting surface. For second refracting surface, ray of light is going from glass to air, means denser to air rod. The refracted ray will bend away from the normal. Bend करेगा. Let your angle of incidence be I2. Angle of refraction be R2. These two are normal, so definitely I1 R1 equal to I2. And angle I2 equal to R1. ठीक है? First refracting surface line हमें apply करिया पड़े Snell's law. Snell's law कौन बोलती? Sin I1 by sin R1 by sin R1 equal to refractive index of the second. जो मीडियम में refracted ray रहेगा that is called second medium. Refractive index of the second medium to first medium that is equal mu g with respect to a. ठीक है? For second refracting surface ना दिया है PQRS मोड़ा दरकार नहीं ठीक है खाली पढ़ूँगी. For second refracting surface, angle of incidence is I2, angle of refraction is R2. Sin I2 by sin R2. Refractive index of second medium with respect to first medium means mu A with respect to G. Like this, button theta multiply करना. Sin I1 by sin R1 into sin I2 by sin R2 is equal to mu G with respect to A into mu A with respect to G. Double mu G with respect to A is equal to 1 by mu A with respect to G. अर्थात बीटा का product must be equal to 1 है ना? ठीक है? Again, I am going to say I2 equal to R1. तो I2 की अगर R1 को करें तले करेंगे ना? तले बाई के sin I1 by sin R2 equal करते 1. Means sin I1 equal to sin R2. That means I1 equal to R2. ठीक है? For first refracting surface, this is angle of incidence. This is angle of refraction. This is angle of incidence. This is angle of refraction. So when the ray of light is finally refracted, that ray, here remember, incident ray, refracted ray, and when finally it comes out from the denser medium, that is called emergent ray. Incident ray, refracted ray, emergent ray. Angle of incidence, angle of refraction. Angle of incidence, angle of refraction को बा angle of emergence को. तो लेकिन proof को ले करो I1 equal to R2. I1 equal to R2. After this angle is equal, this angle means these two rays must be parallel to each other. Means emergent ray must be parallel to incident ray. So when a ray of light is refracted through a glass slab, emergent ray must be parallel to which incident ray. है only there is a lateral. जब भी glass slab न था रेटा ही इधर देखा था. पर देखते कि lateral shift वाला जो lateral shift का फॉर्मूला होता है. तळु पूरा उतना बोले नॉर्मल चीज lateral जैसे कि डिस्प्लेसमेंट है ना बोले lateral displacement और lateral shift का वैल्यू बदल बात है. ठीक है राइट साइड डायग्राम को पहले देखो भले रे that is 3 mark question देखो there is a plain glass slab with parallel faces P Q R S तुमको है जी AB is the let the thickness of the glass slab with small t ठीक AB is incident ray B is the refracted ray C is the emergent ray in the absence of glass slab the incident ray AB must travel along this line due to the refraction now it is passing through this line means the perpendicular distance between incident ray and emergent ray is called lateral shift as a lateral shift of which is x the perpendicular distance between emergent ray and incident ray is called lateral shift ताको कहिबा lateral shift okay से lateral shift expression बात करना देखो this angle is I so this angle is also equal to I opposite angle if this angle is the angle of refraction R so this angle will be equal to I minus R okay ठीक আছে देखो बोले चित्र रफली कराई छी notes is given to you perfectly you just follow this video link with respect to your notes का पाखे रखो video link follow करो का मैं रफ डायग्राम को जे परफेक्ट डायग्राम तो दिया ही है देखो BCE is what type of triangle? Right angle triangle. Sine of this angle कितना होगा? The sine of I minus R. For this right angle triangle, this is P and this is H. This is P, this is H. Only to be CE by BC. So sine of this angle is equal to P by H. What is P? X. What is H? BC. BCF is another right angle triangle. BCF because this is the normal. BCF is another right angle triangle. In this right angle triangle, cos R value बाहर करेगा. Cos R equal to B by H. Cos R equal B, এটা হচ্ছে P, এটা হচ্ছে B, এটা হচ্ছে H. B by H মানে কত লিখবি? BF by BC. BF is equal to thickness of the glass slab. Let me write P by BC. That implies BC equal to T by cos R. BC equal to T by cos R. Okay? Again we see. From this equation, sin I minus R equal to C by BC. Okay? What is C? That is X. ठीक है बोले खुद देखो. That implies CE equal to BC sin I minus R. That implies CE बोले किधर इक्वल X. X equal to BC sin I minus R. Okay? BC जगह कितना होगा? T cos by R. That implies X equal to BC जगह को कुछ कहते हैं T by cos R. BC जगह को sin I minus R. That is equal to T by cos R. Sin A minus B फॉर्मूला को कहते हैं sin A cos B minus cos A sin B. Sin I cos R minus cos I sin R. फॉर्मूला को कहते हैं sin A minus B ର ଫର୍ମୁଲା ଅଛି sin A cos B minus cos A sin B. ପକେଇ ଦେଲି ତାପରେ cos ଟା ଭିତରୁ ନିଅ ଅଛି ବ୍ରାକେଟ ଭିତରୁ T होल इनटू एडी cos R कैंसिल ହେଇଗଲା ରହିଲା କେତେ sin I minus cos I sin R by cos R. देखो रे ऑफ लाइट का कितने एंगल इंसिडेंट करथला से हम दबो कितने एंगल ऑफ रिफ्लेक्शन से दे नकियो तो हमें चेष्टा करिया सब एक्सप्रेशन था एंगल ऑफ इंसिडेंस रे एक्सप्रेस करबा और तो आई एक्सप्रेस करबा ए आई अछि ठीक अछि sin r टा y एक्सप्रेस करबा cos r टा y एक्सप्रेस करबा ये भी आई अछि नो प्रॉब्लम ठीक अछि देखो Snell's law let us come to Snell's law Snell's law mu equal kete sin I by sin r that implies sin r equal to sin I by mu জানিলে যদি sin r আছে আমি কত পারি এখন sin I by mu এতিকি প্লে লিখুছি বাকি উপর গলে বুঝি পর কাম নাই বুঝি সাবেন তুমি cos r equal to square root of 1 minus sin square r এটা ট্রিগোনোমেট্রি ফর্মুলার आंसर ঠিক আছে হলো cos r equal 1 minus square root of sin square r 1 minus sin square r ভাগ করে বুঝিলে sin square I by mu square এটা বলে কি sin square r equal কত হবে sin square I by mu square মধ্যে পকাই দিই से वैल्यू वैल्यू पकेगा हम काम चल रहा है now x equal t whole into t अब तो लिख दो जी x equal t whole into sin I minus cos I टा हम चेंज करेगा खाली खाली r टा चेंज करेगा sin r equal तो लिख दी कहते अरे mu equal sin I by sin r का sin r equal कहते sin I by mu by तो लिख दूं cos r वैल्यू को कितनी कहते हैं 1 minus sin square I by mu square ठीक है ब्रैकेट से सब ओके that implies x equal to t sin a theta को कितना बनाना है ब्रैकेट थ्री के तरह ला 1 माइनस कितना रहेगा cos I डिवाइडेड बाय तो लॉस ऑफ मान करो mu square root of mu square sin square I by mu square ठीक है that is equal to t sin I 1 minus और sin डिवाइडेड बाय mu स्क्वायर भाग में और स्क्वायर रूट ऑफ mu स्क्वायर भाग में से mu पर्टिकुलर रहना कहते हैं स्क्वायर रूट ऑफ mu स्क्वायर into sin स्क्वायर so this is the expression for lateral shift this is the expression for lateral shift okay देखो what are the factors upon which lateral shift depends what are the factors upon which lateral shift depends अगर देखो if I tends to 90 degree so the angle of incident remember যদি incident रे more obliquely incident करिवो अर्थ normal से angle बढ़ी बढ़ी चलिवो if I increases and what is the maximum value of I here it may be parallel to the refracting surface means I is 90 degree যদি I 90 degree হবো sin 90 equal 1 and cos 90 equal 0 তার extra maximum হবো when I equal 90 degree x should be maximum अर्थ lateral shift will maximum what is maximum value पकेबा cos 90 कहते हैं 0 sin 90 कहते हैं 1 पूरा 0 हो गया रहेगा कहते हैं t that means maximum lateral shift a ray of light can occur when remember the maximum value of lateral shift of an emergent ray is equal to thickness of the glass slab means a ray can never be laterally shifted greater than the thickness of the glass slab thickness to अधिका lateral shift ही परिबो नाही अर्थ वर्तमान x lateral shift आउर इंसिडेंट रे क्लोज होइबो आउर कमिबो ये बढ़िबो जाइबो मैक्सिमम इज इक्वल टू थिकनेस ऑफ द ग्लास स्लैब ठीक अछि वर्तमान व्हाट आर द फैक्टर्स अपॉन व्हिच lateral shift depends एट एक्सप्रेशन में बाहर करबा lateral shift increases if thickness of the glass slab increases so the glass slab thickness increases refractive index will also increase lateral shift increases, if angle of incidence increases, if angle of incidence will increase, the lateral shift will also increase. Mu jete बढ़िबो तलटा सेते कमिबो 1 minus 2 jete कम फेरा हबो सेते value बढ़िबो. So when the refractive index of the material increases, then also lateral shift increases. So lateral shift from maximum value is equal thickness of the glass slab. And what are the factors upon which lateral shift depends? Means lateral shift is directly proportional to thickness of the glass slab, directly proportional to angle of incidence, directly proportional to refractive index of the material. That's all about the lateral shift. Students, lateral shift is complete. Let us now discuss total internal reflection and its application. The important point is mentioned to you from the beginning. If a ray of light travels from denser medium to rarer medium, it refracted ray bends away from the normal. Okay? So here, first medium is denser medium, second medium is air. After how this medium is water, this medium is air. Or this medium is glass, this medium is air. Okay? When a ray of light travels from denser medium to rarer medium, the refracted ray bends away from the normal. More will be the angle of incidence, more will be the angle of refraction. More, jette angle of incidence body chalthibo, jette angle of refraction body chalthibo. Hello? For particular angle of incidence, if angle of refraction is 90 degree, then that angle of incidence in the denser medium is called critical angle, and that is given by the symbol C. जो angle of incidence denser medium रे जो angle of incidence पाई rarer medium रे angle of refraction दा 90 degree होगा, that angle is called critical angle. So here critical angle symbol with C. जदि पिले angle of incidence रो value टा critical angle to बढ़ी जीवो, then the ray will never be refracted, but it will be reflected to the same medium or the denser medium जाएगा denser medium को return करेगा. This is called total internal reflection. अर्थात जो ढीले रखना internally से ही reflect होगा. Remember? So this phenomenon is called total internal reflection. If a ray of light travels from, again I am repeating, if a ray of light travels from denser medium to rarer medium, refracted ray bends away from the normal after refraction. You go on increasing the angle of incidence, you see angle of refraction will also go on increasing. For which angle of incidence in denser medium, angle of refraction in rarer medium will be 90 degree, it's called critical angle. That is given by the symbol C. And if angle of incidence is greater than critical angle, then the ray of light striking the interface will never be refracted, but will be reflected to the same medium. This phenomenon is called total internal reflection. The definition from this. Here first medium is denser, second medium is rarer. Let us apply Snell's law. Snell's law of sin I by sin R. So here this angle is angle of incidence I, this angle is angle of refraction R. Sin I by sin R is the refractive index of the second medium with respect to first medium. Mu 2 with respect to mu1. But remember here, second medium is rarer, first medium is here. Mu critical angle expression बाहर में पहुंची. I अगर पकड़ सी. When angle of incidence is equal to critical angle of refraction is 90 degree. R अगर पकड़ sin 90 equal to 1, sin C. Now which one is the denser medium? mu1 or the first medium is the denser medium. That reverse करें. mu2 with respect to 1 with sin C. That mu1 with respect to T हम कहते 1 by sin C. The refractive index of denser medium with respect to rarer medium is called absolute refractive index of the denser medium. So absolute जोड़ने माना 1 को लिखा रहता है. So mu equal 1 by sin C. So what is the relation between refractive index and critical angle? पता लगा कहीं mu equal 1 by sin C. Okay? तो मैं जरा खाता खुली अपने notes का था. Total internal reflections का चार्ट application देखिए. So many applications are there. But let us discuss these applications, very simple applications. Mirrors formation, optical fiber, total reflecting prism, sparkling of diamond, but shining of diamond. मुझे डिटेल टिके ये सब कही होची. Imagine a diamond piece there. When a ray of light, because the face of the diamond is designed in such a way that when a ray of light is incident on the diamond, it enters, because diamond is a refracting medium. Ray will bend after refraction. When it appears to come from the internal to external, from diamond to air, it suffers total internal reflection. Why? Because the refractive index of diamond is 2.4, but its critical angle is 26.4 degree, more or less, very less. Okay, so since its critical angle is very less, so once light enters the diamond, it suffers a multiple total internal reflection. So that reflection here, and when it comes out in a particular shape or particular edge, and if the emergent ray falls to your eye, you see just the diamond as shining. That is called shining of diamond or sparkling of diamond. Okay. तब देखिए मिरज फॉर्मेशन तबे देखिबो मरुभूमि माने करे गछरा को प्ले कि पानी तम नथियो तुम देखाजिबो पानी अछि बोली गछरा को कारण जेतरे गछर प्ले कोट ऑप्टिकल इल्यूजन हबो गछर तुम जानछो इमेजटा पानी रे हुए तुमको लागियो प्ले गछरा उल्टी की देखा होची बट दैट इज ओनली ड्यू टू मिरज हला दैट इज एन ऑप्टिकल इल्यूजन कोन सेटा प्ले मोस्ट इम्पोर्टेंट पॉइंट इन डेजर्ट एरिया द एटमॉस्फेयर इज हॉट द ग्राउंड इज हॉट. The layer of air or atmosphere is in contact, which is in contact with what? Ground is more hot. And as we go on to height, more altitude increases, then hotness decreases, coldness increases. Remember, if air will be hotter, its density will be low and refractive index will be low. So in case of desert area, as we go from the land or ground to topmost of the atmosphere, then density of air decreases, refractive index of air density of air increases, refractive index of air increases. Suppose here is a tree. Bartaman ray of light mo akhi ke asle dekhibi, when a ray of light is coming from top to bottom, that means it is coming from higher refractive index to lower refractive index. Means it will bend away from the normal. In the barambar plane, normal to bend away also, and when angle of incidence is greater than critical angle, there will be refraction. Sorry, there will be total internal reflection. But on total internal reflection here, chitra dekhai bhalo dekho total internal reflection, but every object can be seen in a straight line. जेतेबेले से टोटल इंटरनल रिफ्लेक्शन रेज राख हलाकि बैकवर्ड एक्सटेंशन करिबा जो पॉइंट रे मिसिबो दैट विल बी द वर्चुअल पोजीशन ऑफ द ऑब्जेक्ट आमे ओडी इमेज देखु ताकू कहजे इमेज आ जो ऑप्टिकल फाइबर प्ले ऑप्टिकल फाइबर को कोन दैट इज डिवाइस व्हिच वर्क्स ऑन टोटल इंटरनल रिफ्लेक्शन कोन आजकल देखितो प्ले टेलीविजन ब्रॉडबैंड कनेक्शन पे ऑप्टिकल फाइबर यूज करा होछि कोन गोटे थिबो कोर्ड टे थिबो हला भाबो जा गोटे कोर्ड टे तापर क्लैडिंग दिया हितबो कोर्ड ता हाई रिफ्रैक्टिव इंडेक्स रो बा टेंसर मीडियम क्लैडिंग ता रेयर मीडियम through the help of this optical fiber signal can be transmitted from one location to another location without any loss of energy जेतेबेले प्ले optical fiber भितरे signal पसिला it suffers total internal reflection and comes out from the other end without any appreciable loss of energy. This is called core, and the surrounding is called cladding. Its refractive index is low, its refractive index is high. This is called denser, core is called denser, cladding is called rarer. That means when a ray of light falls from denser to rarer and angle of incidence is greater than critical angle, it will be reflected in the same medium. So due to multiple reflections inside the core, there is no loss of energy, and in this process we can transmit the input signal over a large distance without any appreciable loss of energy. That is called optical fiber. तापर कौन सा total reflecting prism हला an isoscale right angle prism is called total reflecting prism. देखो प्ले चित्र दिखाई प्ले को total reflecting prism आओ कोई बात ना isoscale Isosceles means this side equal this side. This angle equal 90 degree. This is called an isosceles right angle prism. It's called total reflecting prism. Suppose a ray of light is incident on this surface. Okay, this is the normal. This is the, remember, this angle equal to 45 degree. This angle equal to 45 degree. A ray of light are to the but critical angle for glass is 30 degree, but here the angle of incidence is 45 degree. If angle of incidence is greater than critical angle, then it will be totally reflected in the same medium. Same medium reflected है So this is called total reflecting prism. This is all about your refraction at plane surface. Problem discussion करिबा त भले बुझो लाइव क्लास में डाउट क्लियर करिवो त प्रॉब्लम करेबी प्रॉब्लम क्लास पर एग्जाम होबो एग्जाम पर नेक्स्ट गुड बाय.